A very good morning to each one of you present here for this webinar session today. We have a great lineup of speakers for today's session who will be talking about data engineering, the career opportunities, and most importantly, some of the skills that would be required for you to begin a career in this space. Let me give you a quick introduction of all the session speakers for today. We have with us Mr. Karthikeyan Sankaran. He has over 20 years of experience in software industry with focus on business intelligence as well as advanced analytics. He is a passionate data science practitioner with the ability to effectively use technology to solve business problems. Currently in his role at Latent View Analytics, he works at the intersection of business, data, math, and technology to answer business questions using an approach that is simple, pragmatic, and effective. Mr. Karthik has also spoken at several conferences and he has conducted several data science boot camps as well. And he's a regular guest lecturer at many campuses. Mr. Karthik has also completed his engineering at IIT Madras and is an MBA grad from IIM Kolkata. Joining him will be Mr. Siddharth Reddy. He is the Vice President and Global Head of Data and Advanced Analytics Delivery for Banking and Capital Market Clients at Genpact. He has also 20 years of industry experience across the globe. In fact, in his career, he has held front and middle and back office roles in various banks at the United States of America as well as India. He has also consulted with numerous commercial as well as investment banks across the globe in the field of ALM, FTP, liquidity risk, and market risk management. He has an MBA from Illinois State University, as well as a Bachelor's of Arts in Economics and Masters of Arts from, again, in Economics from Loyola College, Chennai, here in India. And joining these two session speakers will be Professor Charanpreet Singh. Now, Mr. Singh has been driving force behind the highly successful data science programs offered at Praxis Business School, and he's one of the pioneers in this field. He has started Praxis full-time program as early as 2011. Professor Singh has over 30 years of experience in organizations such as British Oxygen, Tata Steel, PwC, Hewlett Packard, as well as Praxis. He's a professional and his academic interests are in the areas of education, learning, data science, and communication. And he's also been a mentor to several career aspirants across domains. He has done his BTech in mechanical engineering from IIT Kanpur, and his MBA was from the University of Iowa at the United States of America. So, gentlemen, it's a pleasure to have you all for this session, and I would like to quickly, hand over the session to Professor Charanpreet Singh. Over to you, sir.
Thanks, Pradeep, and welcome everyone to this session. And special welcome to Siddharth and Karthik for joining us here. So what we're going to do here is, basically introduce all of you to the field of data engineering, the kind of careers this domain offers, and what are the skills required, and how can you acquire the skills that are required to create a career or forge a career in this field. So that's what we're going to do. So while we converse, we're going to answer questions like, why is there this buzz around data engineering? And given the economy today and the situation today, is this data, anything to do with data, going to become even more important than it was before? So that is one thing we will talk about. We will also talk about the difference between data science and engineering, because this is something that a lot of aspirants ask us. We have two experts to address that question today, because there are some overlaps, some things which are very different. So what are the differences? And we will talk about what kind of careers are available, what kind of roles, and what kind of career graph that you can look at if you pursue a career in this field. What are the skills you require? How do you acquire these skills? And we are launching a full-time program in data engineering starting a month after this one. And we have the gentlemen here, Siddharth and Karthik, they are representing organizations that have given us enormous support in terms of knowledge and expertise to start the program. So what does this program bring to you, and how can that be useful? So this is in a nutshell what we're going to do. So starting with you, maybe let me start with Siddharth and then come to Karthik. This buzz around data engineering, Siddharth, what is this all about?
Sorry, on mute. So first of all, good morning, everyone. Thanks for taking time out on a Saturday morning. And I wanted to thank Professor Charanpreet and Mr. Karthikeyan for taking this time out and inviting me as well for this session. So this is very close to my heart. This is what I do. This is my, I live and breathe data engineering and data science. I lead a large team globally. But I think it's exciting for me to talk about this. So to your question, Professor, I think see, data science and data engineering are the two most widely used buzzwords in the market today, right? I think you breathe, eat, sleep these words today, and I'm sure it's on top of every aspiring graduate and students as early as even class 6 and 7. When I take my kids to their school and I mentor people there, they have the same questions, right? I think, see, I think the economy we are looking at today and where it is heading is all part of a normal cycle that will go up and down. But it's our mindset and how we look at what people are aspiring to do, and these are two of the key areas that are coming up and going forward for a long period of time. This will become the DNA for a lot of folks. When I was studying in college and trying to do my MBA, learning a database, learning Access, Excel, even knowing how to use an internet in 90s was like, okay, this person knows about the internet, right? I think going forward, these are going to become pretty soon, in a year or two, DSN, DE are going to be part of the DNA, and everybody has to know this like Word or Excel, right? So that's how I look at it. And as we go through, we will look forward to talk about it.
Yeah, Karthik, you want to add to that?
Sure. Good morning, everyone. Thanks so much for joining us for this panel discussion. Thank you, Mr. Siddharth, for it's a privilege to be part of this panel. Thank you, sir, Charanpreet, sir. Data engineering, data science definitely are buzzwords, right? And before I kind of get into the details, the one thing I would say is they are very, very powerful tools, right? Which can help you solve a whole lot of business problems. But it's important to kind of remember that they are just tools in terms of solving problems, right? So that is really what I intend to kind of cover as part of this session on how they are powerful tools, but it is not a magic wand at the same time, right? So how do you really use it in an appropriate manner in order to solve business problems is the essence of this discussion in some sense, right? Now, coming specifically to that question, it's a very simple concept, right? The whole digital transformation that was happening, and all of us are impacted in our daily lives almost on a daily basis for every kind of decision, right? When was the last time we actually went to a bank to transact, right? So digital transformation was anyway kind of expanding and exploding at a fairly fast clip. And this whole, of course, it's unfortunate, this whole Corona thing. But then what has really happened is now the whole digitization is accelerating and exploding, right? And the moment digitization explodes or expands at a very accelerating pace, invariably you're going to have data. At the end of the day, digital transformation, the core aspect of it is about creating large amounts of data, right? And so if you have the ability to work with data, right? And of course, there are many different problems to solve out there in the world, be it business problems or social problems. There are a whole range of problems to solve. and you have a very important raw material now, which is I mean, as they say, right, data is a new oil, kind of probably is a cliche now. But then the fact of the matter is there is lots and lots of data. So anybody who has the ability, going back to Mr. Siddharth's point about the fact that this will become so important as a fundamental skill for all of us, that the ability to use data in the right way, and of course in a very responsible manner, right, in order to solve business problems, I think will make for an exciting journey for a lot of us, right? So that's probably my initial preamble to this whole space of data science and data engineering. It is a buzzword, it is powerful, but it's not a magic wand.
Right. Thanks. So, I think there are a lot of people who are, and that's my experience. I don't know whether this audience would agree with me or not, that there is still a bit of a confusion, because, even when you people introduce this whole subject, you use both data science and data engineering. Now we already have a program in data science now that goes back to 2011, and we thought that there is now a place for a program in data engineering as well. I mean, and not as just a subset of the program of data science or whatever. So what is data engineering? Now I'm asking you a very, very fundamental question. What is data engineering, if you were to kind of define it both from a dictionary perspective and also in a work related perspective? What does a data engineer do? I think that would be something that the audience would like to know, because a lot of them could be students and looking at this as a career, or evaluating it. So whoever wants to go first, I mean, just take it away. So yeah, yeah.
Yeah, sure. See, I think I look at data engineering as an aspect of data science that focuses on practical application of data collection and analysis, right? For all the work that data scientists do to answer questions and the analysis or analytics, or the large sets of information that they are looking at, they have to have mechanisms to collect and validate that information, right? So I would, in simple terms, to simplify it, say data engineer involves in preparing data. They help in develop, construct, or test the architecture that sits below this whole data science or analytics that we talk about, right? So it's more of preparing, analyzing, and basically constructing an architecture that's going to help you do what you need to do from a decision or data science perspective.
Yeah, Karthik, you want to?
So just taking a step back in terms of looking at it at a slightly more fundamental level, right? And again, the words kind of indicate that, science and engineering, right? So what is science? The whole scientific discipline, right, is all about trying to explain how certain things happen, right? And once you get an explanation for how certain things happen out there in the world, right, takes physics, chemistry, whichever scientific discipline that is, right? You then try to figure out whether there's a better way of doing things, right? So it's more research oriented, in the sense that you're looking at certain thing and saying, okay, this is what is happening, right? And the status quo is probably not good enough or acceptable going into the future. So you're trying to understand it and change it for the better, right? And in some sense, science is the bedrock of human progress, right? So once you start figuring out how things happen and how can you change things, etc., then you're turning to things about, okay, how can I improve it for the better? That is science, okay? I'm not coming to data science as much right now. So that is science. If you look at engineering, engineering is all about, it's not as much about figuring out new things, but it's more about using the existing things to derive value, right? So, and if you really look at it, both are symbiotic, right? So without science, engineering in some sense does not exist, because what will you add value on, right? But having said that, you really can't derive value from science without having an engineering discipline, because engineering is the one that brings everything together, right? Puts everything together in the right place, ensures that the value reaches to the right person at the right time, the right context, etc., etc., right? So that is science and engineering. as I kind of see it. And data science and data engineering is just a mere extension of that, right? Data science is, yes, the whole idea is to solve or look at new way of doing things. The raw material is data. There is so much of data. Data depicts the real world in a way, right? Because whatever you do is collected as data points, right? So once you understand that reality, you can probably change things for the better, right? So that's the data science part of it, right? Of course, it involves a lot of techniques, as Siddharth pointed out, about organizing, collecting, analyzing, processing, modeling, all those aspects of it. But at the end of the day, looking at from engineering standpoint, data engineering is the one that really helps you to harness the value from data science, right? So data science is a more of a research discipline, as a more slightly more, I would say, a medium term, a long term kind of a focus. Definitely, of course, short term goals are also being looked at. But engineering is about, okay, I have these tools. How do I bring them together in order to put a recommendation engine in front of a customer, right? How do I really create a fraud solution, right? And then ensure that the fraud solution is utilized in an actual context of a credit card business and things like that, right? So engineering is all about putting things together, ensuring that you derive value from data science. Okay, and once you start looking at it, and obviously the thing is, as I said earlier, these two are very, very interrelated, right? And in an ideal situation, if you kind of mix them in the right proportion, that is where you get the maximum and the best value, right? And just to close it with a final simple example, given all the unfortunate corona thing, to me, data science is about finding the right vaccine, right? Getting or creating the right vaccine is data science in some sense. If you use data, of course, it's data science, but that's science. Engineering is to ensure that once the vaccine is found out, you have to ensure that it reaches the right people, right? Have the whole distribution mechanism in place in order to ensure that people get benefited by the vaccine. To me, that is in some sense engineering. And data engineering is essentially an extension of how do you ensure that data science value is achieved, right, through the engineering process.
So I had a related question here. So, one is, of course, how do we get the value that you derive from the analysis that the data scientist does? How do you productize it and, make it available for the customers or the audience? But what about preparing the data before it can be analyzed also? Isn't that also a large part of data engineering? How do you do the architecture of the data? How do you create the right pipelines? How do you make sure the data is valid, reliable? It is robust, and that it's easy to access and all of that. So does data engineering come before and after data science both, so that the whole thing kind of fits in? Is that the way it is?
Okay, so I'll probably go first on this. Right. So data science, as I said, if you want to really figure out what is happening and how things have got to change, you need to work with data anyway, right? So as a data scientist, you also have to process the data, right? You need to work with data, visualize it, right? All that needs to happen, right? In order to really figure out whether I'm going to really using the data or whether the data is relevant enough for my analysis, right? And whether it's good enough for me to take it to more sophisticated machine learning and deep learning kind of techniques. So the data science person is also a person who kind of understands data and the processing techniques itself, right? But the focus of the data scientist is to really figure out whether the data is good enough for me to do the analysis, to do the research and get the value out of it. Okay. Data scientist per se does not really think about, okay, tomorrow if I have to get this into an application, right? Is it repeatable? Is it trustworthy, right? Is it something that I can actually do it at scale? Now I'm probably handling 1 million data points. Tomorrow my business will grow so that I'm going to get probably a billion data points, right? Can the system handle that, right? That is the job of a data engineer, right? The job of the data engineer is to say, okay, the data scientist I kind of figured out some value from a certain discipline or a process and has developed predictions and insights, etc. The data engineer uses that and says, you know what, if I have to scale it up, if people have to get the best possible performance, right? Look at a Swiggy or look at a Flipkart or an Amazon, right? There's very sophisticated analytics behind the scenes or data science behind the scenes, but what gives it its real power? The real power comes from the fact that you can interact with it, right? If you don't like a product, you can actually put a thing on Swiggy saying that I want a refund, you take a photograph. I mean, the whole application environment or the experience is created with the help of data science, right? So, and that is why I'm saying there are overlaps, but the data engineer is concerned with how do I build a system that is scalable, that is robust, that is future proof, right, and can cater to all kinds of changes in the landscape, and how do I improve the user experience in the best possible manner, right? That's the primary focus of a data engineer, right? Over to you, Siddharth.
Siddharth, you have anything else or on this?
No, but I think Mr. Katkin brought in very, very valid and practical points, right? I think today, if you look at it, the largest analytics organizations are the Googles and the Amazons of the world, right? Everything that we do and everything that we serve is data, and it is end of the day going and getting collected, and that is getting analyzed, right? Probably what we are doing today is also getting analyzed. So yeah, so simply if you look at, if I would differentiate, right, between a data engineer and a data scientist, it's basically one cannot exist without the other, and that's very important. Ideally, from a data engineer, you're looking at more of the developing, testing, and maintaining the architectures, whereas a data scientist would be responsible for developing the operating models, right? So you're here testing, maintaining, and looking at architectures, and there a scientist is actually doing it. You're basically in the engineering piece, you're understanding the programming and the complexity that lies behind the data. And on the other side, you're basically looking at cutting out and looking at analytics or optimizing either a machine learning or a deep learning methodology using the data that a data engineer gets, right? You are trying to deploy a machine learning or a statistical model in one versus a strategic planning or a advanced analytics in the other, right? So more or less, if you simplify it, it's more of building, looking at the pipelines, looking at various extract, transform, load operations in terms of bringing the data that is needed to actually provide, where the scientists may actually look at how do I perform ad hoc analysis with this. So it's very difficult to separate these out because they have to work in tandem. That's how I would look at it.
I will just quote one example which Dr. Shaurav quoted last time when we did the webinar. I thought that was a very, very easy to understand kind of an example. He said, you get onto Google search, right? You put a search query, right? You get the results. The appropriate results that you get is based on a data science kind of a paradigm, right? So data science that work behind the scenes in order to get you the right data. But imagine a case where you put in a query and then Google says, you know what, you come back tomorrow, right? I will give you the results, right? Ensuring that you get the results at that time, right, in a millisecond interval is data engineering, right? And so you see which provides value. Both of them working together provide that value. You don't want an experience where you kind of tell a person, come back tomorrow for the search query to get the results, right? You don't want to do that. At the same time, you want relevant results. So it's basically both of them working together, and that kind of stuck in my mind. That was a great example, I thought.
Yeah, absolutely. Yeah, absolutely. Yeah. So now moving forward, now we come to the crux of it. You know, I think that I'm actually in the process of writing an article for a newspaper, for a media channel, on, you know, what should people do to create careers, you know, build careers and all, because there's a bit of a kind of a depression in what's happening around, and, you know, people think there are no more jobs, or there are less jobs than, or fewer jobs than there were. So how does data engineering as a domain, how does it look as a career option today? What is the demand, and what are they doing? So maybe you could bring in examples from your own organizations, maybe starting with Siddharth. How do we, for an aspirant who's got, let's say, technical capabilities, and now wants to build a career, is data engineering a good thing to look at?
Yeah, definitely. I think we are in a world of abundant information. People want to narrow down their options to the most specific thing, and they want to build their careers based on that. Right? I think, see, learning is something that is going to happen throughout your life, right? I've been in the industry for 21 years, and I'm learning something new every day. And even today, by hearing both you, Professor, and Mr. Karthikeyan, I'm learning something, right? So I think at times people try to box themselves in and say, you know what, I'm hearing the word data science a lot, so let me do only data science. Let
Right.
me do data engineering, or let me do only that. It doesn't work that way. So if I look at it, and I've been somebody who's come with a background from economics, done MBA, have been an investment banker, have done balance sheet risk, ALM, everything, and now I'm running an analytics org where data is the new oil, data is the hub. But if I look at it, I look at data as three broad pillars. One is the entire data provisioning, which is the layer that sits at the bottom. Above that sits the entire data management, and then above that sits the entire data consumption. These are the three broad pillars, and one cannot exist without the other. They have to work, and there are careers for people across the spectrum, up and down. And the most important thing, having been in the industry and a banker for 21 years, is integrating these with the whole concept of domain. You need to understand what you're trying to do this, who are you, what problem are you trying to solve for, end of the day, right? Just knowing a tool or just knowing a programming language, just knowing, okay, I know Python, I know R, and I can become a data scientist, or I know that I'm the best coder and I can do this, at times doesn't help, right? So it's that finer details of integrating all of these, and then also trying to figure out and bringing in the functional and the domain. So today everybody must be hearing the word techno-functional, and it becomes even more important, becoming a domain-centric techno-functional person, because you need to relate the business problems and how do you solve for it on the fly, right? A data scientist does not exist if a data engineer cannot pull the right set of data and set up the right pipes for that information to be collated, right? So in a way, I think there are career options that people need to think a little bit more broader rather than narrowing themselves down. And that's what's going to help them broaden their spectrum and grow holistically. And that's what the industry looks for. When I'm interviewing people and when I'm hiring people, I always know that if I get somebody who has the right attitude and the aptitude, can pick up any of these skills. So I'm looking for somebody who has that ability to think broader and deeper, rather than saying, you know what, this person knows this is coding and he's going to be the best fit, right? So my advice would be to don't narrow down, be broader, and pick up areas that are going to help you build your career.
Thanks. Yeah, Karthik, what is your take on this?
So just to so if you look at LatentView as a company, right, we are a fairly small company in the sense that we are around 750 people, and the whole idea, right, was focusing on hardcore data science and analytics for a fairly long period of time, right? We work with really large companies focused on data science as a discipline. Okay. Around 2 years back, if you really look at it, 100% of our of the whole company of around 700 people was focused on analytics, data science, right? Focused on machine learning and things like that. Over the last 2 years, there has been a big infusion of data engineering people, to the extent that right now around 20% of our company is data engineering. People who are focused on building pipelines. People, I mean, we also have full stack developers to develop the applications on which the models can reside and things like that. That is just a small example of how our organization is also pivoting in terms of ensuring that it is not just going to be analytics or analytical thinking anymore. You need to combine it with engineering skills, because at the end of the day, customers are asking for implementation, getting it in front of the customers and things like that, right? So the moment you start thinking about repeatability, a robust platform and things like that, data engineering is the go-to field, right? And we are continuously seeing a demand for people in terms of growing our data engineering practice at this point in time. And that's one of the reasons why we partnered with Practice also, right? In terms of creating a data engineering curriculum so that we can bring the right mix of data science and data engineering, right, to the organization itself, right? So answer to your question is, I think there is going to be a lot of demand, because I really like this phrase that Judy Appel talks about, saying data by itself is profoundly dumb, right? It just exists, right? So you need to harness it appropriately in order to deliver or get value from it. And how do you really harness it? You need to look at data science in order to help you figure out how can you change things for the better, and new data engineering to kind of figure out how I can bring all this and deliver value to the end consumer. So if you look at it from a first principles perspective, on one hand, you have lots and lots of data. On the other hand, data by itself is profoundly dumb, right? And you see organizations that use data in order to deliver huge value, right? Take a Facebook, take a Google. These have become behemoths, right? And I'm sure Genpact is one such company also, which delivers so much of value, right, using data to different organizations, right? So given the mix, it's only natural to kind of assume that data science, data engineering will continue to accelerate into the future, because data or the whole digital transformation is an irreversible change. And I think that everybody would agree. There is no way of going back to a situation where you're going to reverse the digital transformation, right? It is going to accelerate. It is going to become bigger and bigger. You're going to have data. By itself, it's dumb, but you can solve some great problems with it. So you need people who can act from a data science perspective, understand the business side of the world and solve problems. You need the business people to understand the power of these areas in order to embrace it much better. And you need people sitting in the middle who can bridge the gap between the two, right? In terms of ensuring that, okay, from data science, I can actually deliver value, and data engineering folks are a very important part of that value chain.
Right. So good. So I think that I think more or less we've just to take a look at what we've done since we started talking about it. I think we've kind of answered questions around what is data engineering, and how is it intimately related to data science, and this whole business of making data useful for both the company as well as its clients, right, and getting value out of it, and how the two have to work together to do that. And the fact that today there is an increasing demand of data engineering, because merely analyzing and getting insights out of data is not enough. We need to now make it available to customers in a manner which helps them to quickly solve their or address their problems and all of that. So I think this part is done. Now I think the next thing that we need to look at is, Siddharth, you talked about a broader, people with a good attitude and people who think deeper and broader. I mean, these things are, of course, always good to have and sometimes tough to find, right? Okay, but as a discipline, if somebody wants to start this data career through data engineering, what kind of knowledge, skill sets, and I'm sure there will be a lot of questions on, this is my background, this is my experience, should I get into data engineering or not? And I don't have a technical kind of background, and should I pursue data engineering or not? Or I don't like coding, should I do it? I don't like math, should I do it? These are, I think, I actually talk to students a lot more than you do. You get a very filtered kind of people when you interview them. So I think that a reasonable conversation on skills, knowledge, what works, who are the kind of people who should look at this as a career. I mean, yeah. So maybe this time for a change, maybe Karthik, if you want to go first, and then Siddharth, just yeah.
Okay. So if you look at the way to understand this, right, the whole space before we get to the skills part of it is, and I think we have said this multiple times, but I'm just reiterating, the whole thing is, the whole idea is to deliver business value using a combination of 4 things, right, which is business, data, math, and technology, right? How do you bring, or how do you have that business orientation? And in certain cases, it's very deep domain knowledge also, but a fundamental thing is about having a very strong business orientation, a business problem solving attitude. That's one part of it. Then you are talking about the data part of it, the ability to work with data, the ability to analyze data, model data, etc. Right? Of course, the math part of it comes very close to the whole thing about data and math kind of works together, which is what this whole space of artificial intelligence and machine learning and all those things are all about. And then there is a technology piece, which is the focus of this conversation in some sense, which is basically is a glue that brings everything together, ultimately solving a business problem, right? So business, data, math, and technology are the four pillars, right? That is very important in this area of using data to solve problems. Now, given that, of course, ideally you would want everybody to be an expert on all four, but that's not practical, right? I mean, there is also the practicality in terms of how do you kind of grow into this role. It takes time. Each one is a big area by itself. So it's a question of how do you approach it. So for a data engineer, right, and which is where I spent a lot of my time in data warehousing, data management, BI for around 17, 18 years, right? The important thing is to be an expert on the technology side of the world. And as Mr. Siddharth pointed out, it's not about the tools per se, because a good technology person can learn any tool. That's what in some sense I have done, and I've seen people do that so effortlessly, right? But the attitude should be about, okay, that thing about understanding the technology component. What is it good about it? What are some of the pros and cons of that, right? The technology aspects of it is important. I'll come to that in a second. But it's very, very important that we keep saying business is the cornerstone of analytics, which means even if you are a technology person, a data engineering person, you should have a narrative in terms of saying, okay, what is the problem that we are trying to solve, right? And why are we thinking that data science and data engineering can actually solve this problem, right? So that is what I call as a business orientation, and that's fundamental to everybody. Of course, going beyond that, if you're an expert in finance, if you're an expert in marketing, supply chain, that's great, right? Or if you're an expert in an industry, right? Banking, financial services, insurance, that's also great. But the common denominator is that you should have a business orientation, ability to look at things from a business perspective, and the curiosity to understand business from a commonsensical angle. Why do people buy this product? Why do they pay the price for this product or a service? How is the product getting distributed, right? The ability to read a balance sheet of a company. These are very, very important skills, right? But for a data engineer, obviously doing things in data science is going to take time. But you need to have an appreciation for what the data science field is all about. What are they trying to do? What are these models, right? How do they develop these models? Not in depth. You might not be an expert on math and stats, which is fair enough because you're a technology person, but an appreciation for what is this prediction all about? Why are they trying to predict this, right? What kind of goes behind the scenes? They keep talking about some algorithms. What does it actually do at the end of the day, right? An appreciation for data science is very important for a data engineer. And of course, a very strong technology knowledge and that business orientation, trying to develop that thing around, oh, I will always look for what business problem is getting solved and try and understand it at some level. That I would say are the core skills that are required. Of course, now if you get in deeper into data engineering, there's a lot of things around cloud technologies, for example, distributed systems, right? Those are becoming more important in an analytics context because you're getting lots of data, so you should have the ability to process it at scale. Cloud gives you that whole pay-per-use kind of a model, use it whenever you want kind of a model. So great things to learn, right? So tools are out there which you've got to learn in order to derive value. But I think the foundation should be in terms of, do I understand the concepts? Do you understand how do you put things together and have an appreciation for the other side of the world in terms of saying, okay, what are these data scientists doing so that I can do my job better as a data engineer, right? Probably a very long answer, but hopefully.
No, I think this is one of the meaty part of the whole webinar, really, because people out there, I think, would be figuring out right now and mapping that, okay, what all do I know here, and what do I, how do I look at myself? So I think, Siddharth, anything to add on this? I'm sure you'll have.
I'll try to add a little bit. I think Mr. Karthikeyan summarized it well, right? So everybody's talking about artificial intelligence and augmented intelligence and all that, but I think to his point, I always tell my team and even the clients that common intelligence is the most important thing that we need.
Yeah.
right?
Also, it's rare.
Yeah, and it's again, it bottom line comes down to you can simplify the most complex problem, or you can make the most simple thing the most complex thing, and depends on how consultants sell it today to the clients, right? So again, I would again go down to the three pillars, which I say: data provisioning, data management, and data consumption. And from a skill sets for data engineering specifically, in the data provisioning, which is where we are looking at the entire data integration, aggregation, people should have basic concepts and skill sets related to data warehousing, right? ETL knowledge, some programming knowledge. People a little bit more advanced may know how to do some analytics on Hadoop-based analytics. So SQL, I would say, is the most common language that will help, and it's not rocket science, and it's very easy to pick up. And once you go through a structured program, it's even more easier, right? So the data architecture and pipelining and some of those is where the provisioning aspect comes in. Data management is the second aspect, where the business knowledge comes in on why and how you're trying to solve for the problem. And that's where a little bit more of the business concepts come in. How do you put data quality? How do you put data governance? So the right data is being collected in terms of it being used for data consumption. And that's where you have more visualization tools coming in. You will have scripting, reporting, data analytics. So that's how I would ideally look at it. And with data engineers, that core data warehousing, ETL, how the data flows, and those are the skills that are going to help them set it up. And once that is set strong, everything else is a piece of cake, and others will be able to pick it up. And it's very easy for people to jump from DE to DS. And we actually look at it as one program within Genpact, and we actually call it augmented intelligence, or that's what we look at it as.
Okay, all right, great. Yeah, so I think that so what I could gather here is that you need to be fond of technology if you want to enjoy this job as a data engineer, and because technology would keep advancing, and so you'll have new things to learn and new things to do with data. And I think it's pretty certain that the volume and complexity of data is going to just go bigger with time. So the job of a data engineer is going to get tougher and hence more exciting. And the more the challenge, the more excitement in meeting that challenge, right? So yeah, so I always sometimes you feel great that you are at this age, so you don't have to work for another 40 years. But when I look at data science and data engineering kind of domains, I always feel that this is sometimes I feel that I wish I were 25 now and not what I am. Yeah, because it's really exciting. I mean, I actually you feel that. So so now the thing is the next part, and I think this would be probably where we will kind of close our discussion and go to questions. Is that how do you acquire these skills? Because industry looks for kind of I mean, industry ready is a very loosely used term, but at least industry literate kind of people, that people who can come in and start contributing, and you don't have to train them from scratch. So how do you acquire these skills? And let me make this question a little more let's say comprehensive. You know that I have to do these 5 things before I can get into a data engineering job. And there are options, right? I can do an online program while I work. I can do a part-time stuff that's happening. And as you said, learn a couple of languages. And as Siddharth was saying, that's not data engineering. But a lot of people may want to start that way. Or I say that yes, this career one looks promising because there is a lot of demand and it's going to go up. And in today's world, if you have if you can get a job which you can retain, it's a good option. And the second is that I like it and I want to really learn this well. So I'm going to, if I'm a freshman, it's fine. But if I'm not a fresh graduate, I'm going to give my job up and get into an immersive program and learn this entire piece with all its pillars, the data pillar, the technology pillar, and the the math, little bit of math, not as much as a data scientist would do, and surely the business pillar. And then I go into the industry, so of course things are going to change. And so this is not it's not that I stop my learning, but I will be better prepared to learn the newer things because I have such a strong base behind me. So, but of course, the trade-off is then I give up my job for 9 months, I pay a bit of money, and I spend my time. And so, how do you look at this this whole dilemma? Yeah, I mean, so whoever wants to go first, I forgot who started last. So,
Siddharth, please.
Yeah, Siddharth, okay, fine. Tell me.
See, I think again, my basic advice and guidance to my team, or even to my kids and people who I mentor, has always been, there's never a bad time to learn, right? And so that's why, in fact, at Genpact, we focus on continuous learning. Whatever levels and how many years of experience you have, we have an internally built program, what we call as Genome, which is a continuous learning. All of us at every level have to continuously go through, and we get scored, right? That's the DNA of our organization. Being curious is always helpful, and that is something in today's world people get very easily available on the internet. It's very easy for somebody to say, you know what, I'm going to go do a course in Coursera, or I'm going to do online education and do it. But I think the most important thing is abundance of information that is available in one sense is a boon, and in another sense is a bane, because at times people get confused in terms of how do they structure their learning. And I think that's where it becomes to work with organizations, or for example, even when we went through the program that Praxis offers, it kind of showed us that it brings in that structure. It guides in terms of how you need to go through in a structured fashion, because that's going to help you become better equipped, right, rather than going all over. So so in my view, I think it's better to narrow down the options and figure out and spend that time in terms of what is going to help you achieve the ultimate goal, because learning never stops, right? You can do something now for 3 months, and then in 3 months you can go again and do something else. So my honest advice for people who've wanted to learn in a structured fashion is to enroll themselves in something that is a little bit more, and guidance is more important. And mentors and guidance can happen from various ways, from friends to professors to learned people in the industry. But a structured program is something that I feel always helps, and that's why we've also partnered with Praxis and looking at and getting people through that, because we've seen them deliver and come up the curve, the learning curve, once they get into the practically solving problems for the clients much faster as compared to them doing something themselves and then learning one program here, one program there, because their learning curve sometimes flattens out. So I would look at it and focus a little bit more on a structured program that helps them come up the learning curve faster.
Right.
Okay.
Yeah.
Kind of just adding on to this, right? So the way I kind of see this is there are 3 parts or 3 pillars, right? Which is, of course, curiosity. In fact, they are touched upon it. That's very, very important in this space. Then comes the concepts, and then comes the skills, right? All 3 are very important in order for any career, and more so for a data-oriented career, because it is very dynamic, fast-changing, and it's very powerful and all that. So if you're just looking for skills, and what I mean by skills is quickly picking up an AWS, right? Doing something on, you want to learn quickly Azure, right? You want to learn an ETL tool, right? you want to learn SQL, for example. If that is what your focus is, go for a part-time. There is enough resources that are available outside as MOOCs and all that. Skills, I think you can do it on your own in some sense. And if you have the ability to work with some technology, I think there is a plethora of information that is available, places that are available for you to pick up skills, right? But then the other two pieces, I think, are best done using a more structured program, right? Conceptual knowledge is very difficult to pick up if not for the guidance and the structure that the whole thing gives you, right? So that is where I see this. For example, I mean, again, Siddharth was also done as MBA. So the MBA program that we did way back, right, gave us that ability to think about a business from a slightly more holistic perspective, right? It's not that, oh, I could have still read about a book on brand management or some financial aspects to kind of figure out some of those things, but this is much better because then you know what is good about it and you can analyze the pros and cons, you can hold a point of view, right? So the structured thing really helps you to get to the conceptual knowledge much faster. And of course, curiosity is developed much more because you have a peer-to-peer learning, and you're obviously, I mean, when you do a group project or a team project, right, and you realize in the industry also very much that when you're doing a project is where other person says something and you feel, oh, why didn't I even think of it, right? So that happens again in a structured program through group projects and study groups, etc., etc. So concepts and the curiosity part of it, I think, is best done using a more structured, a more immersive type of a program. But if you already have that conceptual knowledge and you feel you're just going to pick up skills and you just want to kind of dabble with a few tools or keep picking up some tools knowledge, I would say yes. Then probably you can just look for a more part-time or a even if you are disciplined enough, even do a MOOC course and then get on with it.
Yeah, great. I think that a little bit. I would also like to add here because we see students from all kinds of perspectives, and I think two things that both of you said. One is the curiosity part, which is so good, so important here, and the other is the discipline part, which Karthik you mentioned right at the end, because I think a large part of learning also is discipline, and it's a little easier when you're part of a structured program, when it's competitive and all of that. So we have had students at our who've done these 9-month full-time programs with us in data science and now cybersecurity as well. And some of them were not very sure, so they came in kind of half-hearted that I'm not sure I took the right decision or not. But I think within 15 to 20 or 1 month into the program, they said that I think I've done the right thing, because they have another 30-35 students sitting next to them. They are discussing stuff. They have multiple profs to go to. And then they start their own clubs or hackathons, and and they have leaderboards, and so a lot of things happen, right? And then of course there's this campus placement program. So there is again a structured approach. So that, because I think the first entry into a domain is the toughest. As they say, making the first million is the toughest. Once you make the first, the second and third kind of follow. I think a lot of people tell us, everybody looks for people with experience. And unless I get my first job, how will I have experience? Right? So I think campus gives you that comfort, because the recruiters who come to campus know that as far as this domain is concerned, they've gone through a program, and it's not that they've worked in it for 5 years or something. So, and then there's the alumni network as well. That becomes pretty powerful, because I think again, since data science, data engineering are kind of symbiotic. So I think even the data science alumni network that an organization or an institute has would be a great help to data engineering aspirants and newcomers as well. So, but I think 2 points. One is that you should be able to afford it in terms of both time and money and time away from job. That is one, obviously. And the other is that as both of you said, that do you really need it? Are you at a level where a little bit of top up will do? Then you don't need to go through that. But if you feel that you want to transition your career, or you want to look at this as your career, and you don't have the concepts, I think maybe a full time is always a challenge, actually. I mean, to make that decision, but I think so good. I think we had a good discussion. Any closing remarks? And one thing, we're very happy that you partnered us, and I just to tell the audience, I mean, it's not that they got a ready-made program and they partnered us. They gave us a lot of inputs. So a good part of the program is designed the way it is designed because we had inputs from people like Siddharth and Karthik and their organizations. and we are very grateful for that. And yeah, so anything else, and or shall we just open it to questions and see what the audience wants to know?
Yeah, I think, yeah, let's do the
Siddharth, you have anything to add? Anything that I missed out that you didn't
No,
cover
I
as
think,
an answer?
closing, only one comment. I mean, you talked about people being worried about not being experienced and worried whether they'll get a job. I think it's important for all the students to know that the tide is turning, right? In the industry, we look at the new infusing new blood is something that is a must for us. In fact, we have a structure where we want every year 20% of 20 to 25% of our people to come from campuses, because they bring in new skills, new thinking process that helps, and the industry is demanding it, right? Python was not a common or R or Python. These skills were not common 5 years back when I was hiring from the campuses. Today it is, right? So it helps. And at times we have these freshers who come in, are training the seniors, because seniors, once you've gone past that 10 years experience, 12 years experience, we find it difficult to learn these new skills. So we have these youngsters coming in. While we are teaching them experience and practical applicability, they are teaching these other skills. So every time we form a team to work for a client, it is a mixture of a hybrid structure that puts in these youngsters and the experienced folks to solve for a problem. And that's very important. And that's how the business world is going to transform, as we see. And given this whole pandemic and virtualization that is happening, it's going to become even more important. So I don't think people should get worried about, I don't have experience. You have to start somewhere. So stop thinking about it and go focus on the curiosity and the learning aspect, and you'll do very well.
Great. Thanks so much. And now I have an SOS to Pradeep. Pradeep, I can't. I'm not able to scroll the questions, and so I have a very small window to see the questions. So can you help me out?
Sure, sir. Should I read out some of the questions?
Yeah, I think I'll do that. Yeah, great. That would be great. Yeah.
Okay. I'll start off with the first question. This is by Sandeep. He's asking, can engineers with non-computer background switch their career to data science or data engineering if they have maths as a basic background or some bit of those coding skills? Is that possible?
I mean, my answer is definitely possible, right? There is nothing that really, I mean, how do I say, prevents anybody from learning this space. I think we have kind of stressed this enough that it is about getting that overall perspective and drive it through. I mean, of course, you need to spend the time. It is a journey, right? There is no way this can be learned by going through a 2-week kind of a program. It is a journey, but once you get your foundations right, then it's a matter of adding more and more to it. And I mean, your answer is absolutely yes. There's nothing.
Yeah, I would agree with that. I'm not an engineer, not a IIT background. I'm economics with math and MBA with marketing and finance, and I've learned it through the way, right? And it started with learning early in my career, and that's why I said curiosity is important. I could have just sat aside and said, you know what, I'm going to focus on economics and interest rates and balance sheet and hedging and derivatives. But for me to understand that, I had to learn what a simple relational database was. And I started my interest in that by learning Access, right? That was the early, when I came into the work world, Access was the most commonly used relational database I learned. And even till today, it helps me understand and break down things, right? So don't restrict yourself. If you have the interest, I think you will pick it up. It's not rocket science.
Okay, great. The next question is from Ranjan. He says that he has 10 years of experience working as Informatica admin, and for the last 5 years as Hadoop admin. He has development knowledge on these, but don't have much experience in development. And he wants to know which is a better career option for him. Would data engineering be the path, or should he look at data science? Uh, any thoughts on this?
Siddharth, you want to take it away?
Yeah, I can. I think Informatica is the most widely used data quality, data governance tool. If you know Informatica well enough, I can hire you tomorrow. So don't worry, right? So you're thinking too hard. And between whether it is data engineering or data science, you can do both. So don't try to narrow down your options. But to become a data scientist, there are a certain more deeper knowledge, advanced statistical and mathematical applications, and how do you need to think about it, and that is something that you can definitely learn uh, through internal trainings, and we have structured programs where we put people through that as well. And I'm sure Praxis itself has a very structured program on both of these. So
yeah, we do. I think an easy transition would be data engineering, and if you are, if you love math, I mean, I think for data science, I think an interest in stats and maths is very important. I mean, that's what we've seen. So people who are really good with numbers and linear algebra, of course, it's all taught, but then they have that passion to get into numbers. So if you have that, both are open to you. If you are passionate about technology, maybe data engineering is an easier and good transition.
yeah.
I will just add on to that question
sure.
simply because I was an Informatica person when he started. So when somebody says Informatica, I get a little close to it, right? So the good thing is, given that background, I think you can definitely get into data engineering a little more comfortably, right? Unless you say, you know what, I definitely have a facility with math and stats, in which case you can look at data science also. But I think a natural fit would be more like a data engineering kind of a program. But having said that, you have to realize that, who's going to give you that chance, right? The fact, you will have to look at it in two ways. When anybody asks me a question on how will I get into analytics, one thing I would say is anyone can do analytics provided you have that foundational thing that we spoke about and the curiosity, etc., all that, right? Anybody can do it. But still, it's not all rosy out there, because who is going to give you a chance if you have, let's say, 10 years, 12 years, 15 years of experience, right? Somebody has to give you a break, right? And that is where more years of experience, you need to think about how are you going to position yourself, right? What is your positioning in terms of saying, okay, I want to do this. Don't leave it for the organization to figure out what they can give you, right? It's very difficult for the organization also to kind of say, you know what, I have 15 years of experience in ETL, in BI, right? And again, I'm talking about my case, right? But for the organization, they say, what will I do with you, right? So you need to position yourself, and the way I positioned myself was to say, you know what, now I've learned some of these data science techniques, I've done some courses, certifications, etc. I come from a data management, data ETL integration kind of a background. Probably I'm the best person to tell you how to create robust pipelines, how do you create a robust infrastructure in order to do analytics, right? So you position yourself, you enter, and then over a period of time, nobody stops you, right? And most of the organizations, once they see potential in you, right, they will take you, they will ask you to do data science courses, they will get you to all different areas. So think about it in two parts. Learning conceptuals, all that is going to help in your journey. So keep learning that, but have a very strong thing on how do you create and crack opportunities, right? Which is about having your own blog, right? Having your own repository, have a portfolio of projects. Think about, if you're on the other side, why will a person hire you, right? With whatever 10, 12, 15 years of experience. So I think these two in my mind are important things to think about a little distinctly, because otherwise you'll get a little muddled or even get frustrated. Oh, I've done so much, but why I'm not getting a break, right? And I'm just saying that because I've seen many people ask me that question. But potential is huge, and you being an Informatica guy, my sense tells me that you're a good technology person, and so probably you can position yourself as a data engineer by going through probably a structured program like what Praxis offers, if again time, money, all that is in your this thing. And then once you enter, over a period of time, you can get into multiple areas. And again, no organization will restrict you from gaining knowledge of other areas also. that's the kind of that's what we want, right, in people, that you're an all-rounder in some sense.
Multidisciplinary kind of.
Multidisciplinary kind of stuff. Yeah.
Yes, what else do we have?
There's a question from Lakshya. This is something on the technical line. Now he says he wants to begin his career in data science and particularly data compression algorithms. Which language should he choose between C++ or Python as his base?
I don't know. So I'll have to be frank enough to admit that compression, I've kind of heard it, read about it in terms of it's important, and especially now it's all about how do you do model compression, right? Huge models, how do you compress them and all that, but I don't know the specific tools that are the best thing for compression as such. I'll have to display my ignorance here.
Yes, so that would, yeah.
No, I'm ignorant on that as well, but I'll definitely find out and come back to you, Professor.
Yeah.
And maybe we can keep his contact details or name, and we can share it.
I think he will be there on the thing and we can answer it, but I'm just saying that it's a very sharp and narrow focus, that this is exactly what you want to do. I mean, so which is great to see. I mean, but again, maybe you can do much more than that as well. But we'll get back to you. Yeah.
No, but like the way Siddharth answered this question, right? Saying that is what curiosity is about. I'm sure, right? We will go back to kind of figure out why is this important at all, right? And then we'll try and figure out how this happens now. And that I think is a very interesting thing, also interesting dimension to how we learn. But you learn from everything, right? So questions, answers, and so yeah, nice question. So we'll try and get back.
Sure. There's another question from Abdul. He says that he is a senior software developer. .NET full stack is what he's mentioned, and he wants to transition his career to data science, and he wants some guidance on how he does that, and if his current skill on .NET is of any help.
Okay, so again, going back to it, if you want to be a data scientist, right, you need to have a facility with numbers and the motivation to really think through it from a math and a stat perspective, right? To run the programs, you might not need it, but if you're a data scientist and that's what your career is going to be, sooner or later, you're going to be confronted with problems where you need to look into the algorithms, fine tune them, adapt it for your own situation. And unless you know how the things work in the background, you will not be able to really use it for your purposes in the best way possible, right? So my thing is, if you want to get into data science, be very, very sure that you want to get into the math and the stat part of it. Of course, learn the algorithms and things like that. But given I don't know whether your .NET background will be very relevant for a data science kind of a discipline in that sense. But the good thing is, if you want to be a data engineer, I think it'll be very useful, because data engineering in some sense also requires all the things about developing applications, the thought process on how do you look at functional requirements, non-functional requirements, which I'm assuming, because in my life I have handled web technologies, and to me those are some of the most complex things I've handled, right, in terms of developing large systems and things like that. So that knowledge will be useful from a data engineering standpoint, and so that could be your entry point, and then you can probably figure out whether you're really interested in the data science part of it and get into it if at all required, right? But you can make a career by appreciating the other side, as I said, on the data science, but really be focused on developing your data engineering skills. And that is the .NET experience would directly be relevant in that case, is what I would say. So that you want to add anything?
No, I would agree. I think that would be a natural progression more into data engineering, and being a .NET developer and stuff. That would be the natural progression, and then master that, and then you can master the other one as well.
Sure. There's another question from Aditi. She would like to specifically know what are some of those tools and technologies that one has to learn to be relevant as a in a data engineer role.
Okay. So if we have to kind of put out all the tools out there, I think this whole discussion will probably take like 4 or 5 hours, right? There's just so many tools, and there are new tools coming up in the market all the time, right? But broadly speaking, when I look at data engineering as a discipline, which is what the whole curriculum is also about, there are these kinds of data warehouses, ETLs, data marts, operational data stores kind of construct, which is kind of, you can think of it like legacy data infrastructures in organizations, right? And companies have invested millions of dollars in terms of developing those kinds of tools and systems. So that is one part of the story. Then the other part of the story are all these new age technologies, which is more distributed systems, Hadoops of the world, right? Where you can process large scale data, streaming data, right? You're talking about NoSQL databases, right? Which is if you cannot store it in a SQL engine or a relational database, you store it on databases which have a different structure and things like that. So those are some of the tools from a storage as well as a compute perspective, right? A whole lot of tools in that space. And of course the cloud, because cloud seems to be a natural fit for analytics at scale. And so some of the cloud technologies like whatever, Azure, GCP, you know the things. And the thing is, the moment you say tools, right, if you just focus on AWS I think has some 600 different tools for different functions and all that, right? So tools, there's a plethora of tools, but if you bucket them at certain levels, I think I would say legacy systems, all data warehousing, ETL, dimensional modeling, data stores, things like that. Then there are these distributed systems and cloud technologies, right? Those are probably the broad range of skills that one would need to have in order to be a successful data engineer.
Okay. Yeah, so I need to, so the way Siddharth, you're saying something.
No, I think Mr. Karthikeyan summarized it perfectly.
Okay. So the way this program is also structured is the same. We spend the first part on the legacy and give you solid ground, foundation on that, and then we move to the new big data environment, so to speak, with all the new technologies, Hadoop and Spark and all of that, and moving on to data lakes and things. And then we also take you through a little bit of introduction to machine learning. And I think the thing that both Siddharth and Karthik said, that you need to know what the data scientist does and you need to have an appreciation of it. So we're not here to make you experts in that, but at least you get an exposure to that, reasonable exposure, which makes you can then interact intelligently with the data scientist and also the business applications. Right. So I think that for your data engineering journey, probably all these are required in some sense.
Yeah.
Okay. Great. There's an interesting question from Rahul. I'm going to slightly rephrase what he's trying to ask. His question is, for people who have say 15 plus years of technical experience and who have now chosen to change their career path to data science, how keen are companies, to hire such category of people, as they're relatively new to data science by doing some sort of a program or a course, but their larger part of their work experience has been non-data science?
I mean, that's a slightly tough question, so I will let Siddharth take it up.
No, so is the question, I'm experienced technology person for 15 years and I want to get into data science, and the organization's looking for it. Is that the summary? Yeah. Correct? Is that fair?
Correct. How keen will companies be to recruit somebody with 15 plus years?
So I'll be honest. I wouldn't say it's very easy, right? Because data science comes with a certain set of expectations, and especially when you're hiring somebody into the market with 15 years, right? You're not going to come in as somebody who is a novice or an intermediate person. You want to come in as a senior person. So obviously, if you have 15 years, I'm assuming in that 15 years, you would have done something that is going to put you up on the ladder, right? So it's important to sell yourself in terms of how that adds credibility and you up the curve, right? And just don't look at it as just a data science, because like we said, from a practical application business perspective, we are not just looking at just somebody who knows the skills and just comes in and then from day one can do data science. You can't do that. You need to be able to apply what you have learned and then solve a business problem. End of the day, anything and everything that we're trying to do in the world is solve for a problem. It could be the smallest one or the most complex one. So looking at an applicability of that is what will actually define in terms of where you can come in. And then the second piece is, would somebody take you in and train you up to do it? Yes, but they are going to look at on where you're going to fit, and if there is a specific problem that you fit in, even if you're 30-40% there, organizations will take that chance and take you in and say, you know what, he fits in. The balance, I think we can train, because that is the important part the organizations are looking for.
Cool. The only thing I will add on to that is the fact that the more experienced you are, right, the real trick is to say it's not about transitioning to a new area. It's the next logical step in your career, right? So for example, you have handled certain things, right? For again, taking my own example, data warehousing, BI and all that is not data science, but this could lead to data science in some sense. So, right. So you present yourself as a person who's taking the next logical step of, I know how to handle data. I know what data can be put to use, right? I have some appreciation for it. Am I not the right person to help you or help the organizations make that kind of a transition to kind of combine the legacy infrastructure and the new age infrastructure to solve problems using data science, right? If you're able to make that connect, then I think a lot more opportunities will open for you, right? But if you have a narrative, and this I've seen it in my own personal way and also with some of my friends, etc., the moment you say, I don't have any experience in data science, but I want to be a data science person with 15 years of experience, then you kind of lose the battle in some sense straight away, right? So I think the narrative should be, make it like the next logical step. And for that, you need to think about it a little bit more and saying, okay, what all have I done in my career? For all you know, you would have spent 15 years in a different, I don't know, an SAP kind of an environment, but you've been working in banking and financial services, right? And you would have solved a lot of different process related issues and problems and functions for a bank. You can use that knowledge to kind of come in and say, you know what, banks face these kinds of problems and they can be solved possibly using data science. I've read about it. I've explored it a little bit more. Then you're making that as a next logical step and saying, now that I know what banks do and what inefficiencies exist in banks or insurance companies, I would help you to solve some of those problems using data science, right? Make it as the next logical step is what my addition to Siddharth's response would be, rather than saying it's a transition.
So I have some experience in this, because we've had students with 0 years of experience to 18 years of experience. 18 is the longest we've had. So one thing I have seen, that people who come with a bunch of experience, most of the people who joined us and who came with that had a reasonable understanding of themselves, right? So they were very aware of what they had learned, what they could do well, and so your interview happens at a more mature level. Some of them had handled project management. So if you are a good project manager and you have data science skills, then automatically you bring in a lot of value to the organization, because a youngster may not have those kind of skills, administrative, because project management is team skills, leadership skills, a lot of things are involved, meeting deadlines and all of that, and the whole maturity you bring. So I think, yeah, I think both of you said that very clearly, that how do you position yourself and what do you bring, what value do you bring? Those 15 years, what value can it bring to my recruiter? I think you need to be very clear about that. And if you do that, sorry, yeah.
No, I think that's one. And second, see, it's in our typical mindset that a career is always an upward sloping curve, right? So there will be ups and downs. And if you're passionate about data science and you want to learn, even if you have 15 years experience, look for an area that is going to make you, maybe you'll go down 1 or 2, but then that's going to make you jump up faster, right? So yeah, you'll have to think about it.
one of the we have these interviews. So one of my interviewees, I told him that you already worked for 15 years. He said, yeah, but I have another 20-25 years to go. So so I am looking at those years rather than what I have already spent. So I am willing to take a bit of a dip because I have so many more years to look for. And I think that this skill, even if I get it today, I'd rather get it today than tomorrow because that will be even later than what it is now.
Correct.
So that's another great attitude to have. So I actually, I mean, I have nothing to say there. I said, if you want to do it, you're welcome.
And the other interesting thing to add to that is job is just one dimension to that, right? What if you want to be a freelancer tomorrow, right? This probably gives you a lot of opportunities. What if you want to be an entrepreneur, right? Data oriented companies, right? There's so much of scope in terms of solving different problems, right? So the knowledge is important. Oh yes, if you want a job specifically, then that positioning is important, but the knowledge opens up a lot more opportunities for you in terms of I mean, your own freelancing work or start a company and things like that, which probably doesn't open up if you're in a different domain or a different area.
Great. Thanks for sharing your perspective on that question. There's another question from Krishnakant. The part of his questions have already been answered in the previous discussion. I'll just read out a relevant portion of his question. Now he's saying, is data engineering going to dominate data science because there are auto ML packages now? How true is that?
Okay. Good. Interesting that because it's a very interesting dynamics, right? Everything will get automated once people know how to do it, right? The fact of life is people will try to automate stuff, right? And that is why it is very important to kind of look at how do you bring things together. And that is what I think we've been stressing quite a bit as part of this talk also, right? Saying that please don't get focused on one specific tool or a technology. It is good for you in the short term, probably even the medium term, but the long term play is how do you bring multiple skill sets together and with a focus on solving a business problem, right? So data science will continue to evolve in terms of auto ML. Again, there are just fantastic tools that can help you run your own machine learning algorithms and all that. But think about it from, again, if you take a step back and look at it, machine learning by itself has limitations, right? You can't get causal inference out of machine learning techniques, right? And isn't that important for a business decision making? Of course, yes, right? So auto ML, for all its fantastic thing, yes, can help you in solving certain types of problems, probably do it much faster, but it lacks interpretability. It does not provide you a view of uncertainty, right? It doesn't provide, I mean, this is all limitation of machine learning by itself, right? It doesn't provide you causal inference. So yes, AutoML can help you solve a specific set of problems, probably do it faster. But if you look at the whole range and gamut of problems that you can potentially solve, then it's not about one. It's not a fixed pie, right? That one thing, it's not a zero-sum game in some sense, right? So it's just one expands and the other thing contracts. No, it is the pie is expanding. There are a lot more problems to solve, and AutoML is one such another small thing which pushes the bar even further in terms of doing things much faster, cheaper, more accurately, and things like that, right? So that would be my response to your question.
Okay.
Yeah,
Okay.
I agree.
Right. Yeah.
I agree.
Right.
I think I mean, for every, I mean, the number of jobs in data engineering are probably becoming more than the number of jobs for data science. I think the nature of the discipline is such that you probably need a larger team because there is so much data, and you don't need so many people to analyze the data as you need to manage the data. I mean, that's the sense I get from people we work with in the industry. I don't know if either of you would agree, disagree with that.
So that you want to?
Yeah. No, we have in both. See, like everything is evolving, and I mean it's an evolution, right? So if AutoML has come and somebody has created it, that's why it came. So something else will come, right? So it will, as long as we exist, I think in our lifetime, I think new things will keep coming, and we will keep building new things, and it'll keep innovating itself, right? So I think that, but yes, there is think of it as a funnel, right? So basically, again, it goes back to the three pillars: the provisioning, management, and the consumption. The consumption actually sits on top. That becomes the small pyramid where everything that gets done in the data engineering and the data provisioning world, it funnels up, down, and that's where the consumption layer is what you ultimately present and leverage. So it's bound to have a larger base for data engineering and data management, and then it goes down to the consumption. That's where you will use the visualization or the data science aspects. Yeah, and it will change over time. Sometimes if the bottom pyramid is done, then more time will think of a project, right? When we are doing, we spend a lot of time here, and then we spend very little time on how do we actually give the results to the client. But if we don't do the data provisioning and the data management, the data scientists are just basically sitting there and doing nothing.
Yeah, I would kind of, accept that statement that there are probably more data engineering jobs per se in terms of quantity than data science jobs, because data science is a more expert-oriented field. It's, again, I would think of it like people in white coats doing something, right? So it's more research-oriented. It's more about figuring out how to change things, etc., etc. But of course, it is expanding because you need to figure out the right problems to work on. But data engineering, the nature of the problem, again, think of it like you'll have to put things together. There are multiple tools, technologies, somebody have to understand those technologies, see what is the right fit for this problem. So there is a lot more quantity of jobs available from a data engineering standpoint.
Okay. I think we are almost run out of time, but there are a lot of questions about the program itself, the PGP data engineering program itself. Professor Charanjit, if you could, briefly highlight some of the USPs of the program, that would help answer most of these questions.
Yeah, so I'll try. I'm sure that Karthik and Siddharth can also add on. So yeah, so I think that the need for this program came not from us, because it came from the people who were our regular recruiters for our data science program, which was doing very well. And they said that, while we are hiring data scientists from you, we also need people who can do this, and this. And it was obviously not possible to add that, because we would have had to add another 6 to 9 months to the program to get all that done. And anyway, it's not possible for everyone to do everything, So then when that there was a consistency in the feedback that we got from some of our recruiters, that we thought that let's start looking at this, because we as an institute also, we have made data our centerpiece. So we have provisioning and application of data engineering, and also the analysis of data, which is data science, and how to make data secure, which is cyber security. So we run a program on that as well. So that's when we started data engineering, and then we had a lot of options as to how do we do it. Do we do a shorter program and all of that? And then we realized we had got very good returns from doing an immersive full-time program for our data science piece. And when I say returns, it means the careers our alumni are enjoying now, and the kind of equity they enjoy in this whole field. So we decided to go the same. We understand this method, and we decided to go the same method. So I think the USP, I mean, people can teach data engineering. It's no rocket science. But I think what we did better then even when we started our data science, now of course we do that very well, is that we went to the industry right at the beginning. We spoke to them, we found out what what is required, and we in fact, in the structuring of the program, I remember Karthik was very insistent that the business part has to come in, and we would send him drafts and he sent them back with changes, and all of that happened. So right now, I think we have a very balanced program, which is very rigorous. We love rigorous programs. We love to put students through that rigor, and it will give you a holistic view of what are you doing as a data engineering, and why are you as an engineer, and why are you doing it. And it will cover the traditional data architecture. It will cover the new technologies that would be taught by practitioners, because I don't think as profs we can teach that as well. And then we will have this overlap with data science, because that's a large part of your work would be in combination with data scientists. And we will cover cloud, and we will cover business applications. So I would say the it's a very comprehensive and a very topical, current, contemporary kind of program. We have a very strong placement team, which is anyway working with our data science and PGDM and cybersecurity programs. The recruiters, I think in some of them are going to be the same. So we are in fact, seeing whether we do the placements at the same time or separately. The capstone project that we have as a very important part of the program. We are in fact in future thinking of doing the capstone project with cross data science, data engineering teams, so that you actually get a feel for the real world. So the fact that we have a very strong data science program running, I think is going to, these two programs are going to feed off each other. So there's going to be an ecosystem which I think would be quite. We're looking forward to it. We're waiting for physical classes to start. But if we can't start physical classes, we'll still go ahead and start the beginning of the mid-month after this one. So that's, I think, that kind of describes, I don't want to, kind of say it's the best program in the world and all, probably it's not. But I think it's a good, solid program which will make you learn. You have no option not to learn. And I think we'll be able to get you good opportunities because there are huge opportunities in the market. So Karthik and Siddharth, you want to add anything?
The thing why we thought this whole thing with Praxis is very interesting is because fundamentally you're a B school, right? And again, during this whole discussion, we have been stressing on the fact that it starts there. That's the cornerstone for anything that you do with data, right? And so the DNA of a B school is very important to drive that curiosity, to drive that thing about understanding the business, etc. So that is one big reason. And you are already successful data science program, and we really like the fact that you're always trying to see how we can combine these two in some way, right? So you can kind of feed off each other. So that we thought was a very interesting aspect, which we didn't find in other places in some sense. And of course, the fact is, once we started working with you, are also very open in terms of saying, how do we look at this whole data engineering thing itself as different pillars, rather than boxing it into right from the start. The interesting part was, I don't think there was any stress on, we'll only teach AWS, we will teach Azure, or we'll teach SQL. We will teach, all that is all enabled through all the projects, etc. But what we will teach are the concepts and why people do what they, how do you really look at a problem? How do you bring in the different concepts, etc. Which again, we really liked working with the entire team. And of course, sir, you're a visionary, so we like working with you.
No, I think very valid point, and then I think one thing that I would add is the concept of embedding what businesses are seeing into your curriculum and constantly interacting with us and asking for inputs. That's more important, and I would stress on that, because when we talk to our clients and we say that we are working with the academia and the industry, and we are telling them that this is what is needed and this is who we are hiring, it goes a long way, right? They want to know that constant churn and interaction is happening, and that's a big selling point for us when we talk to our clients as well.
Great. Yeah, Pradeep, I think that kind of answered the question. If you have anything else.
No, I think that would be it. There are other minor questions which I would obviously share it with your team, and if somebody could respond to them, that would be great. So I would like to wrap up this session, and a big thank you for all you gentlemen out there for taking time off and coming over to this session and explaining to our audience the whole aspects of data engineering, how different it is from data science, what data engineers do, and why data engineering should be our top priority as a career option in the field of data science. And also Professor Saranjeev for explaining us the overview of the program itself. So I would like to thank you once again, and I would also thank all the audience who made time to be part of this session.
Yeah.
Thanks.
Excellent. Thank you so much.
Yeah.
Thank you.
Great.
Have a good weekend. Thank you.
Great conversation.
Thank you. Bye-bye.